Here's an interesting question. How many Clif Bars would you have to eat to have enough energy to jump to the moon? Interesting question. Turns out that my beloved conservation of energy can solve this question very, very easily. So here you are on the Earth, and you want to jump up here to the moon. So here's you, and here's this jump, right? Okay, first thing we have to ask ourselves is, how much speed do we need in order to leave the Earth's atmosphere? Well, that's called the escape velocity, and the escape velocity for Earth is 11 kilometers per second, also known as 11,000 meters per second. Right? If you could only jump with 11,000 meters per second, you're free from the Earth's gravity and you can jump over to the moon. All right, so this still begs the question, how many Clif Bars do I have to eat in order to have the energy to do that? All right, so just like any conservation of energy problem, I start with E1 equals E2, right? The energy I have here before the jump must equal the energy that I have just after the jump. All right, so what energy am I consuming before the jump? Well, that's the Clif Bars, right? So I'm gonna eat N Clif Bars. And what kind of energy will I have just after I jump? Well, I have 11,000 meters per second velocity, which means I must have kinetic energy at that point, okay? All right, so now we just have to know how much energy is in each Clif Bar. All right, well, a Clif Bar, last time I checked the wrapper, which was 10 minutes ago, I saw that it was 250 calories, which is actually kilocalories. So 250 kilocalories. How many joules per kilocalorie again? Turns out that there is 4,184 joules for every kilocalorie, right? Which means the amount of energy in one Clif Bar in joules is 250 times 4,184, which is, what is it? What is it? It's 1,046,000 joules. Okay, that's one Clif Bar. All right, so in other words, N times 1,046,000 joules per Clif Bar must equal the kinetic energy. And we know kinetic energy by this point is 1/2 mv squared. All right, fantastic. What is the mass of a typical human? Something around, let's say, 70 kilograms, right? Okay, so we're getting somewhere here. We have N times 1,046,000 joules per Clif Bar must equal 1/2 times 70 times the speed that we need right after we jump, which is the escape velocity, which is 11,000 meters per second. Okay, all right, so now we just put all this into our calculator, multiply this, divide by that 1,046,000 joules, and I get an N value, in other words, the number of Clif Bars, to be approximately 4,048, or we'll just round to 4,050 for good measure. All right, interesting question. So, in order to jump to the moon, you have to gorge yourself on over 4,000 Clif Bars just to have that energy. And that's assuming a perfect conversion of all this energy into kinetic energy. Gotta say, I love a Clif Bar, but don't think I can do 4,000 of them.